because when we start scripting and getting into programmatic type languages, we're really beyond the scope of SQL. They've named those things like Transact SQL, Transact being short for transaction. So a Transact SQL script is a script file that includes select statements, DDL commands, data definition language commands, DML commands to update the database. All those different kinds of commands can be included in a script. And so that's why we call it Transact SQL, because it's more than just structured query language. So in this chapter, we would like to be able to solve a problem programmatically. And at the very end, we'll try using the command prompt to connect to our database. Somebody said their mic ripping. Hey, Zad. My crazy thing doesn't. There we go. Scroll up in the chat. And you should see the link. Okay, he's got it. All right, everybody's getting there. So good job, you guys. We'll do something to stay warm. I don't want to go out there when it's 10 degrees. So we want to take a look at scripts and how to use them, talk about the difference between a scalar variable and a table variable, the scope of local variables, the use of cursors, some different types of tables. Some of these tables we've actually used in the past and some we have not, but we'll talk about how long do these tables last, temporary tables, table variables, and derived tables, and a little bit about dynamic SQL. And then we should be able to explain what each line of code does in a script. So here's a script. You guys have run scripts like this before. In this script, we create the database and then we use the go command. Every time we run a go command, that's considered a batch. So a script file can have multiple batches. So there's our first batch where we create that database. And then in our second batch, we use that database and create some tables. We've seen that we've had to use the go command after the use also. So we might actually need 3 batches in this script file. But it's just the same as the script files that you've created to create and update your tables. Okay, how's that? Okay, sorry about that. Zoom updated and it keeps turning it off. So do let me know if it stops again. Thank you, you guys. Much better. Thank you. So whenever we are creating a script, there are some statements that have to be in their own batch, meaning they have to have a go statement after them. And those are mostly these create statements. So we've seen those requiring the go statement for us to be able to use them. Now, Transact SQL gives us some additional statements that we can use for program control. So we have an if else, a begin and end for looping, a while statement for looping. We have a break statement to break out of a loop, a continue to continue a loop at the test condition. We have a try catch statement for error control, a go to statement for branching, and a return statement to return to a previous call. Some other statements that we can use are like the use statement to specify what database we're going to use, the print statement, declare to declare variables, set to set values to variables, and the exec statement to execute like a stored procedure. We've seen the use statement. It's just use and then the database name. Our print statement is going to be print and then what we want to print. So some things are going to be very straightforward for us. Let's look at the script here that they've supplied to us. This script starts out using the AP database. We'll use our database. It declares a variable amper total due with the data type of money. Whenever we use the declare statement, we'll look at the syntax here in a second, but you'll see it's like a lot of different programming languages. We could put a comma between variable names to declare multiple variables on one line as long as they're all the same data type. We can give variables initial values. We'll see all of those things. Now, we have to use the set statement. It's kind of like pseudocode. So if we want to update the value of a variable, we have to set it. So in this line of code, we're going to set the variable total due equal to the sum of all of these outstanding invoice amounts. So that's going to be a summary query that's just going to return one value, and that value is going to be placed into our @total due variable. Then if our total due is greater than 0, we're going to print out this message. Otherwise, we're going to print out that all of our invoices are paid in full. Okay, let's create that script. I have SQL Server Management Studio open. Can you get yours open? Let's see. If I can get it over where you guys can see it. I need to connect. Make sure I'm connecting to our server. And I'm going to post that Google Doc link again in the chat if you hadn't had a chance to fill that out. They said it's not letting you scroll back to before you were in the meeting, so. All righty. I'm going to expand and get into my database, even though I know I'm going to use that use statement. So let's create a new query. So for this one, we're going to use our database. And then we're going to start out declaring our variable. Again, it's a money data type, and its name is @total due. Then we're going to use the set statement to update its value. And what we want to set it equal to is the result of a select statement. Let me get my screen oriented a little better. So I'm going to set it equal to the select statement. And I know Isaac is saying, didn't we create a view for this? Yeah, we did. This time we're not going to subtract all of the things. Notice we're not subtracting our credit total. So let's see if it even works right. So our script is coming along. We've got our variable declared. We're setting it to the sum of this select statement. Missing a parenthesis there. Now I'm looking at this example and it does have a semicolon there, so we'll see what happens if it decides it likes it or not as time goes on, and we'll get rid of it if we need to. Now we're going to use an if statement here, and you'll see that the if statements are formatted very similarly to most of the programming languages that you're used to. We use the same operators as we would use in a where clause. So if our total due that we've calculated is greater than 0, we're going to print out a message. Total invoices due equals. Now, in their example, they go down a line and continue on with that string. So we're saying we want to print out our total invoices due as a variable length character using that format number 1, which is probably our standard money format. Now, if that's not the case, we'll do our else clause and we'll print out this message, invoices paid in full. So let's look at our syntax a little bit. Notice that we have a semicolon at the end of each line of code. We don't have a semicolon after our if and our else because they have bodies. So anytime we have a body, we wouldn't have a semicolon. We should be able to run this. Now, in our last chapter, we were saving views, and we saw that we actually created that view in the database as a saved entity. Notice that a script is not like that. A script is just a bunch of code that we can execute. So we can save it off to a file so that we can run it later and save it to have it later, but it's not an entity that's going to be saved. Hey, can you guys hear me now? I'm using my phone. I don't know what's going on with my mic, but it doesn't want to work. Okay, so I think we should be good then. Thank you. All right, we'll phone it in here. All right, so I don't know, because a lot of places we see the go statement after the use, and in all of their examples, they're not showing it. So let's try running this without that, and you guys will be able to tell more than me if there's a problem. But I'm going to go ahead and run this. What's it tell you? Did it work? Okay. So that may be a version thing, that in the older versions we had to have that go statement after the use statement. So we'll leave it out if it's not causing us any trouble. So notice how using the TSQL, the Transact SQL, lets you kind of almost create a really nice report output for your users. So you can go a little bit further than just creating SQL and dumping out kind of a table or an Excel spreadsheet for them. You can give them some good information. Am I distorted from my phone? It must be my house. My house doesn't want me to talk. It wants me to just go back to bed. Huh, okay, thanks. Hopefully it'll be okay. I guess I'm gonna have to throw away this webcam and get a new one. I love that. Cool, so we got our first script built, and it was a pretty good one. Let's look at some of the rules then. The declare statement. Whenever we're talking about, oh good, thanks, Keegan. Whenever we're talking about creating a variable, we're going to use the declare statement. Notice when we're using TSQL, our variables start with an @ sign. Okay, so they don't start with any other things, just @ signs. Now, after our variable name, we specify our data type. We can have a comma with another variable in a different data type, or like I said, we can have a comma and another variable name before the data type if they're the same. Now, when we set a value to a variable, we have to use the set keyword, and we could use a select statement to set variables as an alternative. So it can take the place of the set keyword by selecting specific data from our table into specific variables. Now they mentioned scalar variables. Let's bring up Google and see what that means. What is it? So I see all this great stuff. I have to declare it. I'm getting that idea. I understand that. So a scalar variable stores a value with no internal components. So that means that it doesn't have a table. It doesn't have any sort of other things assigned to it. It's just a variable. Okay, so we're going to use the declare statement to declare them, set to change the value, or select. Now in this script, let's go ahead and create this script. We're going to use a select statement to set a value, which we did in the last one, but we're going to use some different syntax. So let's try this one. In our SQL Server Management Studio, if you want to save this first one, like I said, since these script files are not saved in the database, we do want to save our source code. And I'll just go to my documents folder, and since I'm not at school, create CIS250 folder. And this will be outstanding script. Great. So I love my clicky keyboard, but I know it can be a little overwhelming probably to you guys. Sorry about that. Okay, let's use this other script to create a new query. And again, we want to use our database. And this time they put a semicolon after the use statement. We always put our semicolon in because you guys are such good habit forming people. Now we want a variable called max invoice. It's going to be a money data type. A min invoice. That's going to be a money data type. Percent difference. This is going to be a decimal data type, and it's going to be 8 digits long with 2 digits of decimal places. So very close to money, right? Now we're going to declare invoice count is an integer. And vendor ID var, which is going to hold our vendor ID, is an integer. In our first set statement, we're going to set that vendor ID var equal to 95. Now, those of you that have been working with SQL in your programs, your C# programs or other language programs know that we could use this then as a parameter from our program so that we could select a specific variable if we were running this script, which we probably wouldn't do in a program, but we could. Okay, so I'm going to set that vendor ID to 95. Then I'm going to set a max invoice value equal to the result of a select statement. And we want to select the maximum invoice total from our invoices table, where our vendor ID equals that vendor ID variable. So one query to set the value of our maximum invoice variable. Now another query to select our minimum invoice value. In this select statement, we're selecting our minimum invoice total into min invoice, and we're going to select a count of all of those invoices into our invoice count variable. Now we need to continue that SQL statement. Nice. So we use that SQL statement to set the value of 2 different variables. Now that we've got our minimum and maximum, let's calculate the percentage difference. So we're going to take our maximum and subtract our minimum, and then divide by our minimum times 100. so that we can do that standard percent difference calculation. Now, we've done all this work and we've got all these variables set and we've done all these SQL statements and select statements, but we've got to output some values. So let's set up some print statements. We're going to print out maximum invoice is get that so you can see it, hopefully. So here's our print statement for our maximum invoice. Our minimum. And again, we want the nice sentences here. Oops, need semicolon. Let's print our difference. Maximum is we're going to print out our percent difference this time. So we're going to print out our difference, and then we want one more print line. We're going to print out the number of invoices, the count that we kept, and again, we want to put a period at the end. Let's see, and I left my period off of this line because they're all going to look pretty. So we should go through our script here, set up our database, declare our variables, set the vendor that we're interested in, gather the data from the database about that vendor, and then print out our information. Let's put some comments in. We'll do a block like they've done. Information here. It's just more like a program. For a given vendor, select the match invoice, and invoice, and calculate the percent difference. Okay, how's that? That's a big one. Let's see. We've got everything. This one is in your book and in the presentation. If you're missing anything, let me scroll through it so you can look. All right, if that looks good, then let's try running it. Cool. So that was vendor ID 95. I don't know if I can remember any others. Let's try 93. Is that one? Nope. Well, I'm not thinking of any of our others. Let's try one. Well, we have a lot. I guess I could just use one, huh? And I'll execute that for vendor ID number 1. No invoices. Well, I'll just go back to 95 then, and you get the idea that we could change that if we wanted to. Oh, awesome. All right, so that script does a lot. It uses some variables. It uses some summary queries to fill in some variable values and some calculations. So we see we have a lot of different options there. We can declare a variable that is a table by specifying the data type table. So in a script, we can just create a table, and after the keyword table, we're going to have all of our column names, data types, and column attributes like primary key or identity and all of those kinds of things. So we can actually create a table for our script. So this is a table variable. Let's try this one. Super powerful. I want to save this one. I'll call it min-max diff script. Okay, so let's create a new one here. Okay, so our table name is going to be big vendors. So notice our variable name is still the same layout. We just have to start it with an @ sign. And then we have that keyword table. After our table, we're going to have our column specifications. And we want a vendor ID with an integer and a vendor name of 50. Oops. I want that semicolon after my closing parenthesis. So there's my table declaration. Now I need some data in that table. So let's use an insert command. And we want to insert into our big vendors table that we just created. What do we want to insert? Well, let's select some stuff. I'm going to indent that so we can tell it's part of that insert statement. We're going to select vendor ID and vendor name. Remember, those are the only 2 columns we put in our table. From our vendors table, where our vendor ID is in this list. Now the list is going to be the result of a select statement, where we're going to select vendor ID from all of our invoices. And we only want to know about the vendors where their invoice total for that one invoice is greater than 5,000. We're going to call these our big vendors. Okay, so in our script, we declare our big vendors table. We insert some data into it, and now we're going to select from it. Now in this select statement, we're not going to be redirecting our output into a variable or anything, so we'll actually see the result set from this select statement. So we don't have to do a print for everything. Let's just see what all we've got out there after we fill it up. All right, let's put some comments in here before we run it. So we're going to create a variable table and fill it with vendors that are large invoices. So let's try it. Okay, in our result set, we see the output from that final select statement for our big vendors. Now, if I were to try to run this again, is that big vendors table still out there? Can I still get to it? Let's try. Oh, no, it's not. So notice that that table variable only lasts for the execution of the script. So let's add that to our comment. Table variable exists only when the script is running. Let's save this script, and then we'll use a table that's just a little bit different. So let's save this one. And I'm going to call this table variable script. Now, the script that we're going to create is going to use a local temporary table. So this is a little different than a variable table. So for this one, we're going to start out with the select statement. Top one. That's not very many vendors, is it? We want to know the top guy or gal. And we want an average of the invoice total. Now, the select into is key here. We're going to create a local temporary table. We can tell it's a local temporary table because its name is going to start with a hashtag. We're going to call that table top vendors. Oops, typo, there it is. All right, so our select statement, we're going to be creating this local temporary table, and it's going to have one vendor in it, that's going to have the average invoice total. That's why we're ordering them by descending, so I can find the top one. All right, so that's going to give us a table. Now we can use that table. Let's try it. One more. Okay, let's take a look at this script before we run it. What we're saying is, find us the top vendor based on invoice total averages, and then we're going to be selecting the vendor ID from our invoices table. But we're only going to get that top vendor. So we're going to use that top vendor number to find the latest invoice for that vendor. So we should be able to run this. And we see that our top vendor with vendor ID 110 and their latest invoice was this date. Could we add our average invoice total? No, because we are doing a summary query here. I guess we could. Let's do another select statement. And let's just select everything from that top vendors table, so we can see what else is going on in there. Oh, wow, look, it's different, isn't it? So much different than our table variable. Let me run this anyways. Now we can run our select statement after our script has completed. So our local temporary table is going to stay around. It has a longer life expectancy. Let's put some comments in this script about all this stuff. So our local temporary table has a longer life expectancy than that variable table. It's going to be around, like, as long as we're connected with our session. So let's put that in. So as a developer, I might have an SQL Server window open so that I can work with some test data, and I could keep that temporary table working the whole time so that I can keep using it. So this is a local temp table. Local because I'm the only user that can see it, so you guys can't get to it. So let's try this next one. It's going to be a global temporary table. Let me save this one. Global temp table script. Oh, no use statement. actually, let's just leave it out like they have and see what we get, because the name of our table here with 2 hashtags specifies that this is a global temporary table versus local. So I'm just going to create the table. I want SSN underscore ID is an integer. It's going to be an identity column. I'm going to keep their social security number. Bad, bad, bad. Sometimes I have to, though, right? Now, in their social security number, I'm going to do some fancy footwork here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what are we doing there? We're generating a random number and then multiplying it by a 10-digit number to come out with a 9-digit number that we can use as a social security number. So we're just going to generate some random numbers. Notice that the ceiling command is going to truncate any decimal place that we might have. And then we're casting it as a big integer. And then we're casting that as a varchar, which I've got to get in here still. With format number 9. And then we're going to put some data into our table. So in our script here, doing, like I said, some fancy footwork, as we created our table, we said that our default value for this social security number is going to be a randomly generated number. So we can just do some insert statements. And since our first column is identity, that value will be automatically generated. Since our second column has this amazing default, it will automatically be generated. Now I'm going to go ahead and put in a select statement. And let's see what you guys can do. I think you will be rejected at some point, probably in creating the table. So let me know what it does to you. Why can I never find the chat? Oh, so one of you got it created, huh? You got it created. So everybody has access automatically to create these global objects. Oh, Nick got it done, yay. So we're all using Nick's. Let's try to select from Nick's. Just do your select statement. And we should all be seeing some stuff. Can we insert? Should all be able to insert. So it's kind of like that sequence we were using last week, only in this case, we're looking at an entire table. So you should be able to all add values. Oh, look at you go. There we go. We got some values in it. So make that table go crazy. So this is really handy for if your project group all needs to access the test data table while you're working on things so that you can keep everything working. Perfect. Okay, that's a really good spot for us. So we've seen some variable declarations. So far, we've seen some scalar and local variables, table variables, a temporary table, and our local and global tables with the hashtag names. So the different variable names, notice that the server uses those to identify what kind of table this is. Now, next time, we'll continue on and look at some additional syntax, get into our if-else statements and our looping statements. So if you have time and you want to work on the assignment, save those kinds of questions for next time, but you should be able to do some of the basic scripting this time. Okay, I found the chat. Does anybody have any questions before we go? Because I've lost the chat again. I just have a terrible time with the chat. What was that? I'm not sure if that was you guys or something in my house. All right, so I'm going to call us good, and stay safe, stay warm, and thanks for coming. I think that we're pretty good. Yeah, I will upload those. The blue microphone. Okay, Guang, I'll send them to you. Let me do that right now before we end the chat. I'll save this one. And remember, they're all in the PowerPoint and in your book, so we didn't really change anything from that. But let me post them here. Yep, I will get it in OneDrive. All right. Now set, and I'll see you Thursday. Hopefully the weather will cooperate better. Practice with the scripts because they are super fun. We finally get to do some programming with our SQL stuff. So let me know if you have any questions, and I'll be on campus by 1 or so. So I will see you then. Thanks.